Beginning of Unit 5. Unit 5 is all about linear functions. And in this video, we're going to talk about learning target 5A, which is rate of change and slope. By the end of this video, you will be able to find the slope of a line given a graph and find the slope of a line given 2 points. So we'll be able to compute the slope from a visual representation as well as from an algebraic perspective. So our definition of a rate of change. Rate of change is defined to be the change in our dependent variable over the change in our independent variable. Back in Unit 4, we talked about what a dependent and independent variables are. Remember, our dependent variable, this would usually be our y, and our independent variable, we usually use our x for. So a shorthand notation for this would be this delta y over delta x. So this symbol right here that is a triangle is called a delta. It's a Greek letter, and in math and in a lot of science classes, we use it to represent change. So delta y is meaning the change in the y variables over delta x would be our change in our x variables. Slope is defined to be the vertical change over the horizontal change, or our rise over our run. If I look at this from a graph perspective, our rise is the vertical in the blue. How far have I moved up or down? And technically, we don't always sometimes rise. Sometimes we could fall instead if our slope is going down. And we'll talk about those two different types of slopes. And our run is our horizontal distance. So what is the difference from my first point on the left to my next point on the right? The rise, since it is the vertical change, is the same thing as delta y. And our run, since it's a horizontal change, is the same thing as our change in x, or our delta x. Which is why then rates of change and slope of a line are actually the same thing. They're just two different phrases or two different words that represent the same concept. Our formal definition of how to compute slope algebraically is what we'll talk about next. So if I have 2 points, x1, y1, and x2, y2, the slope between those 2 points is defined to be y2 minus y1 over x2 minus x1. You'll see here it says slope equals m equals our definition. M is just the variable, or not a variable, it's the letter we use to represent the slope between 2 points. And we'll see that as we dive later into this unit and we look at a bunch of different types of equations of lines, we'll always see that m is representing our slope. And by definition, that would be y2 minus y1 over x2 minus x1. And since we cannot divide by 0, I do have the added condition in here that x2 minus x1, our denominator, cannot be equal to 0. Let's look at some examples about how to algebraically compute the slope given 2 points. So our instructions say, find the slope through the given points. In question 1, we have -1, 0 and 3, -2. So when we look at this in terms of our definition, we need to be able to identify what our x1 and our y1 is, and our x2, and our y2. It doesn't matter which one I call which, but I need to make that choice, so which one will be my first point and which one will be the second. Since our -1, 0 comes first, I'm going to call that x1, y1. And since our second point comes second in our list, I'll call that x2, y2. Technically, I could flip-flop the names of these, but what does need to be consistent is that whatever x1 is coming from, y1 is coming from that same coordinate pair, and x2 will always be with the y2 in the coordinate pair. Now, when we go to find slope, I'm going to do my y2 minus my y1. So my y2 is -2 minus our y1 is 0 over x2 minus x1. Where our x2 is 3 minus our x1 is going to be a -1. Since I have minus and negative, I'm going to put parentheses around that to make sure that I'm going to distribute that negative sign. Simplifying this down, -2 minus 0 will give us -2. 3 minus a -1 is the same thing as 3 plus 1, and then we know that 3 plus 1 is going to be equal to 4. I want to reduce my fractions down and my slopes down as much as possible, so -2 over 4 would be equivalent to -1/2. So -1/2 then will be our final answer for slope in example 1. Okay, let's look at example 2. So in example 2, I have 1 comma negative 3 and 4 comma negative 1. Why don't you guys pause the video and calculate the slope on example 2 on your own first, and then we'll check it together. Okay, let's check our slope in example 2. So our slope definition says y2 minus y1 over x2 minus x1. Remember, m is the letter we use to represent slope. So we need to start with our y2. That will be our negative 1 minus our y1 will be negative 3. Remember, since I have minus a negative, I do want those parentheses here. Or if you want to go straight to writing it as negative 1 plus 3, you can do that as well. In our denominator, I need x2 minus x1. So I'll need 4 minus our 1, since 1 is our x1. One thing I want to point out here is that although it doesn't matter which point I use as x1 comma y1 and x2 comma y2, it does matter that I'm being consistent. Meaning if I'm going to use the second point to always be my x2 and my y2, then if I use that in the numerator for y2, I need to use that in the denominator for x2. So you can notice the numbers that are stacked on top of each other here, the negative 1 and the 4, are coming from the same coordinate pair, just like the negative 3 and the 1, which are stacked on top of each other, coming from the same coordinate pair as well. Let's simplify this down. So we get negative 1 plus 3 over 4 minus 1 would give us 3. Negative 1 plus 3 will give us 2. And I end up with 2 over 3. I cannot reduce that fraction down anymore, so that will be our final answer for slope. Now we don't want to convert any of these to decimals because it's important to see the fraction, because that's actually going to help us as we move on later in this unit and learn how to graph these. And we're going to want that fractional format of it so we can really see what is our rise and then what is our run, since our definition of slope is really coming from our vertical change over our horizontal change. So the fraction is important to keep. Okay, let's look at example 3. It says 3 comma 7 and negative 5 comma 2. Why don't you guys pause the video and calculate the slope first? Okay, let's check example 3. So I need y2 minus y1, so I'll have 2 minus 7 over x2 minus x1, which will be negative 5 minus 3. I can simplify that down. We get 2 minus 7 will give us negative 5 over negative 5 minus 3 would give us a negative 8. Although I can't reduce 5 over 8, a negative divided by a negative will give me an overall positive number. So my final answer then will be positive 5 over 8. Let's look at example 4. It says negative 2 comma negative 3 and 8 comma 1. Why don't you guys pause the video and calculate slope on your own first? Let's check number 4. So we want y2 minus y1, so 1 minus a negative 3 over x2 minus x1, so 8 minus a negative 2. Simplifying that down, we get 1 plus 3 over 8 plus 2, so we end up with 4 over 10. I want to make sure I'm simplifying my fractions as much as we can. So I end up with 4 over 10. They're both divisible by 2. So I end up with 2 over 5. And that will be our final answer for example 4. So in these first 4 examples, what we practiced doing was, given 2 points, how can we find the slope? And we computed them algebraically using the definition of y2 minus y1 over x2 minus x1. Let's look at some graphs now. So in our next set, let's just look at the first 2. It says, using the graph given below, find the slope. So in example 5 here, I have a straight line that's moving up as I move from the left to the right hand side. And I need to figure out how to find the slope of this. Well, to find the slope, all I need is 2 points. So on this graph then, I get to pick any 2 points I want, and then I can use my definition from above and calculate our slope. So when we look at this, I see 1 point right here at 1 comma 1. We have another point, so I'm going to put a purple dot there, and another point over here, which would be at 1, 2, 3, 4, comma 3. And then it looks like they gave us another point over here at -2, comma -1. So we really have 3 points here. It actually does not matter which 2 points we use to find the slope. So we want to just pick our favorite 2 points on here. Let me make that a little bit clearer. That was 1, comma 1. So you have the choice now, and we get to make the choice which 2 points do we want to use. I'm going to go ahead and use the 2 points that have all positive numbers just so that my arithmetic's a little bit easier. But if we wanted to, we could use any combination of these 2 points and we would get the same answer for slope. And that's a really good way to actually check your work, is you can pick 2 points, find that slope, and then pick 2 different points on the same line, and those slopes should be equal to each other. If they're not, then we must have done something wrong as we computed it and we made an arithmetic error. So let's start with, we're going to use 1, comma 1 and 4, comma 3 for this example. When I go to calculate slope, remember my definition, I'm going to put our definition over on the right hand side, is y2 minus y1 over x2 minus x1. So when I go to calculate my slope then, my y2 will be 3 minus my my y1 will be 1 over x2 is 4 minus my x1 is 1. We can then simplify this down. 3 minus 1 will give us 2. 4 minus 1 will give us 3. I cannot reduce 2/3 anymore, so my final answer of my slope will be 2 over 3. Another way to calculate the slope on a graph is to actually count it. So if I scroll back up and we look at this picture that we had of our slope, we had to remember our rise over our run. So our definition of slope is rise over run, so we're looking at the change in y over the change in x. So I could calculate that by counting on the graph. So if I start at 1, comma 1, I've moved up 2 values, and then I've gone to the right 1, 2, 3. And that's matching the fact that my slope is 2 over 3, since I rose by 2 and I ran by 3 then. So my rise over my run. So when we have a graph, there's actually 2 different ways we can compute this. We can compute it by using the algebraic definition and doing y2 minus y1 over x2 minus x1, or we can count it on the graph, and if there's graph paper on there, that will make that a lot easier if we want to count it instead. Either way, both methods will get us to the same answer, so it's actually a good way to do both and check your work as you go along. Okay, let's actually jump to example 7 next, since we already have the graph up here. So this time we have a line that's sloping downwards. So why don't you guys pause the video and compute the slope on example 7 first. Okay, let's check it together. I'm going to first do it algebraically. So I've got to find some points on here. I notice I have what we call a y-intercept right here at 0, 1. So this is a y-intercept since it's intersecting the y-axis. I also have an x-intercept here at 1, 2, 3, 0. And this is called an x-intercept because it's intersecting the x-axis. We have one more point that they gave us on here, which would be at -3, +2. We can pick any of these 2 points that we want to use to find the slope. I'm going to use 0, 1, and 3, 0. I'm going to first compute our slope algebraically. So y2 would give me 0 minus y1 would be 1 over x2, which would be 3 minus x1, which would be 0. Simplifying this down, I get -1 over 3. And that will be our slope. Let's look at it graphically. So graphically, it's my rise over my run. Or in this case, I'm not rising, I'm actually falling. So my fall over my run, I notice I went down 1, and then I went to the right 1, 2, 3, which is matching up then with the fact that my rise is now a negative number. So I have a -1 since I'm actually falling, over our run, which was 3 again. So I fell by 1 and then I went to the right 3, which matches up with what we computed by using the definition. Let's look at example 6. So in example 6, we have another graph here with the line that is pointing downwards. Why don't you guys pause the video and compute your slope right now? Okay, let's check example 6. I'm going to start by checking it algebraically, so let's find 2 points. I've got 2 comma negative 2 down here, and then the other point I have is up here, which would be negative 3 comma positive 2. So I only have those 2 points. That's fine. All I need is 2 points to find the slope. So let's write this out. I'll need y2, which will be negative 2, minus my y1, which will be positive 2, over x2 minus x1. Let's get enough space. There we go. So simplifying this down, I'll end up with negative 4 over 2 plus 3, which would give us, we need a little bit more space there, negative 4 over 5. And I cannot reduce that any further, so that will be my final answer for slope. Now, if we look at this from a graph perspective, that means that I should be falling 4 and then going to the right 5. Since, remember, I have my rise over my run, so let's check. I go down 1, 2, 3, 4. So that's representing our negative 4 going down. And then I'm running by 1, 2, 3, 4, and 5. And that does match up with our slope being negative 4 over 5. So looking at these 3 examples together on the graphs that we've seen so far, on example 5 we got a positive number, and if we look at our line, it's going up towards the right, versus on numbers 6 and 7 we have a line that's going down, and that kind of makes sense that my slopes then were negative since the line is falling down over time. Okay, let's look at example 8 together. So in example 8, I have a line that's actually a horizontal line. So I have a horizontal line right now. I can still try to find the slope. I'm going to need 2 points. So I notice there's a point right here, which would be at 1, 2. There's a point out here that they gave us at 1, 2, 3, 4, 5, 2. I mean, I have an infinite amount of points I could find on here. The one other one I noticed that's standing out would be negative 2, 2, and I've got a lot more on here. We get to pick our favorite 2. I'm going to use 1, 2 and 5, 2, and let's calculate our slope. So our y2 would be 2 minus our y1 is also 2 over our x2 minus our x1. Simplifying this down, I end up with 0 over 4, which we can reduce that further. So 0 divided by a non-zero number is always going to be equal to 0. So there's a sign that I have hanging in my classroom. I'm going to add it over here to the right. On it, it has the question, divide by 0. So I get this question a lot in all of my classes, and it says underneath it, there's one sign that says okay, and one sign that says no. So what okay is referring to is when you have 0 in the numerator over a non-zero number, that's okay to do. That will give us 0. On the flip side, if I have 0 in the denominator and a non-zero number on top, that's a big no-no because I can't divide by 0 in math, so that will be what we call undefined. And I'll write out our full word down here. So we would call this undefined then, since we divided by 0, or UND you'll see as a shorthand sometimes. So in this case, we're in the okay case because I have 0 on top over a non-zero number on bottom. So this is okay to do, and it will simplify down to be 0. Now let's think about this from a graph standpoint. What that's representing is the fact that I have no rise. I did not go up and I did not go down. And when I look at that line, that makes sense. Because it's a horizontal line, there is no place to go up or down. All I can do is run between them, and in this case, I moved those 4 units between them. But because I'm not going up or down, I'll always have 0 over a non-zero number, so my slope will be 0 each time. So for a horizontal line, we're always going to get a slope of 0 then. Okay, let's look at one more example, and then we're going to do a summary of our different types of slopes. because so far we've seen a positive slope in example 5, a negative slope in example 6 and 7, and then a 0 slope in example 8. Okay, so example 9 gives us another graph. I need 2 points to find the slope, so I have 3, 0 there. They also gave me 3, 3. I could pick a lot of points on this. This would be 3, -2, but all I need are 2 points, so I'll use 3, 0 and 3, 3 to find my slope. Remember, it's y2 minus y1 over x2 minus x1. So when I simplify this down, we end up with 3 over 0. So this is that other case on that sign I was talking about, where if I scroll back up for us to see it, this is the second case here where it says n divided by 0, or r no, and that happens when I have 0 in the denominator, and that ends up being undefined for us. So for our answer down here for example 9, 3 divided by 0 will give us a value that is undefined. And referring back to that quote board, that was this no case where I had a non-zero number over 0, so I get a value that is undefined. Now this type of line is what we call a vertical line. So that's telling us that vertical lines have slopes that are going to be undefined then. So horizontal lines in example 8 gave us a slope of 0, but in example 9 we can see that vertical lines are going to give us slopes that are undefined. Hey, let's summarize this in a chart so we can see all 4 different types of slopes. So our first slope that we saw was our positive slope. We saw that in example number 5 with the graph there. We also talked about negative slopes, and we saw that in examples 6 and 7 with the graphs. The difference between these two is the direction that the line is slanting. So in a positive slope, it is slanting upwards from left to right. So in math, we always read our graphs going from left to right. So in this case, my line is going up over time, so it is slanting upward, which would represent a positive slope. In the negative slope case, it is representing downwards or slanting downwards from left to right because the line is falling over time. And we saw that in examples 6 and 7, which is why in examples 6 and 7, our answers for our slopes were negative, versus our answer in example 5 was positive, since I had a positive slope. Our 2 other cases are our horizontal lines, which happen when we have a slope that is equal to 0. So this was example 8 for us, was one of our examples that we saw. So any horizontal line will always have a slope of 0. And then our last type of slope is a vertical line, and vertical lines will always have slopes that are undefined, and we saw an example of that in example 9. Altogether, those are the 4 different types of slopes that I can have, which will help me not only when I'm graphing, but it can also help me check my work, because as we saw in the prior 5 examples, if we're given a graph and we're asked to compute the slope, then we want to make sure that our answer makes logical sense. So in example 5, if we were to compute the slope here, we want to make sure that our value would end up being a positive number, versus in this negative slope picture, if I were to calculate the slope here, I should end up with a negative number since I have a line that is going down. And that will help us as we move forward and we start talking about, well, what are equations of lines in our next learning target?